Hi, my name is Mads Jesper and I'm from FlowHow. In this video I want to show you how to use Symmetry in a runner system if you have more cavities in Moldex3D release 17. I'll show it in Designer and Project. I've made a model of my system with two parts and a runner system, but when I want to use Symmetry, um, I will not use this cavity and this runner, so I have I'll blank this or hide this, and I've trimmed the system like this. So this is a solid, but I will also show you how to use lines. So I have made some center lines of the gating of the runner system. And these I'll also hide because I'll not use those. So what I'll do is I'll export this one. I'll go to I'll export this as a step file, step part, symmetry, like that. I'll hide that, and then I'll export this one. File, export selected, edges. I normally export lines as edges. Run lines, and also just export this one, export selected, step file again, because it's a solid, and I'll call it the runner solid. This is what I've prepared in the CAD system. If it's a quite simple runner like this, I would always use center lines. If it's more complicated with a lot of different features and so on, and different shape, I would use I would I would prefer to use a runner as solid. Now I have started Moldex 3D Designer, and I'll start by importing the parts. It was on the desktop, part, symmetry. I have the part. Then I could use, of course, the gate and the runner wizard here, but I've prepared my runner from the CAD system, and I'll just import. We start with the curves, import curves, runner line. It's co-runner. I can change this if I want. I get something in like that. One thing I forgot up here. If it's boundary layer, I would generate hex like that. If I'm interested in the runner, it's the best resolution on the mesh you get with hex based. So I hit here, file, save as, yeah. I'll just right click here and give it properties, 3.5, 5, and the top should be, let's say 0.8, like that. I hit here 3.5, 3.5, and let's say 3 and 4. Ah, that was the different way. 4, 3. Okay. Then I have the possibilities to specify a point. I can do it here. That's the melt inlet. And then I have the set symmetry configuration. I'll do it here. And I'll just say half because I have 2 cavities. Then it actually knows it's placed like that. I could also choose a different layout by changing this. And not here because I don't have any. But there are some possibilities. So I just hit OK. You can't see it now, but it's actually a symmetry. And then I'll just mesh it. Modify node seeding. Give it 1. Okay. And I'll generate the mesh. Just take it in one step. Now you can see I got my symmetry face here based on that, and I got my connection here. So now I have the model. Next step is just save mesh file. Even though I have only 1 cavity and a split runner, it calculates like it's 2 cavities. I'll just give it a desktop, doesn't matter. Yes. It's ready for simulation. And now just make it the same with the solid. I'll just say save as, and I'll call it symmetry under solid. Yeah, okay, it was capital, but doesn't matter. And to delete, I want to get rid of the mesh. The easiest way is just go into generate, keep attached solid mesh, no. Then it's gone and out here. And I'll delete these things away with the lines, and I'll import step file. I have the solid runner here, and just double click it, and I can go to code runner like that. And I go to 2 and say specify face up here. Now I can't use this. Yeah, I have to use boundary conditions over here. I think set boundary condition here. Select a mesh object, this one, yes. Add, yeah. Mill inlet face, no. It should be a symmetry face. Volume half, yeah. I'll click here. Say OK. And now I've defined the symmetry face. And then I have to modify node seeding on this one. I don't want to modify the node seeding on this one. So what I'm doing is I'm just hiding this part and saying modify node seeding and say 0.6 maybe. Let's see if that's yeah. And you can see it makes quite fine there and fine there, so it knows it's in contact. This looks okay. And I want to generate then surface mesh. Have the surface mesh here, and then I'll just generate again. Say OK. I'll save, and now I'll just have to export. Say mesh file, part symmetry solids, and I save the MFE file. Okay. That's the mesh preparation for both the lines, runner as lines, and solids. I have now started the Moldex3D project, and I'll make a new project. I'll call it Symmetry underscore release 17. I don't like this background, and I'll import the mesh. I'll just take the one with lines first, and then go to material, new material, this one maybe, doesn't matter. I'll make a process, new. If the picture doesn't look like this, you can go here in the options and change it to classic mode. The simple mode you can't really do anything. This is the machine input. Next, the filling time, and just give it something 0.5. No profiling of the filling. Switch over. Packing time, I have to give it a long enough packing time, otherwise I cannot see when it freezes off and if it's big enough. So I'll give it 5 seconds. I know my part is 1 millimeter, and in this ABS I know that it's around this, but are you in doubt, just give it long enough, and I can give it 6. Doesn't matter. Change this to refer for machine pressure, and I have to define the packing pressure. I change this for here and say not 700 bar for such a small part. It should be maybe 300 bar. Next, cooling. I don't have a cooling in my part, so now I've got the process, I've got computation. What's important is that the packing results here, I have enough of those. So inside here I just check, yeah, they are equally distributed, so 29 is fine in this case. Cooling, warpage, task manager, local hosts. Yeah, I can do that. Finish. And now this one is ready to run. I'll just make a copy of it. I'll just give it a name. I right click here and take the first, and I'll say Symmetry 3 pack time PT5. I normally also write IT like this, and 300 bar, and lines, runner lines. Oops, like that. Just copy this. I don't have to. No, it was it was runner as lines. And then I'll just copy this run. Only run data input. I right click here, copy run as a new run. It asks if I want to jump to the new one. Yes, I want. And I double click the modify run data. I pick a new mesh. Just export it. It's the solid mesh. Material is the same. Process. It asks if it should make the new process based on the old one. Yes. Next, next, next. Finish. Okay. Computation. No change. So check run data. Finish. Now I've used the same process and the same calculation conditions here. So now it's just starting the job. I can do that up here. Where was this? I use, if I want to start 2 jobs at the same time, I use this batch run to add, modify, fill pack. Modify, pack, save. Okay. Now the simulations are done, and I have a results. I have a filling results here, and I have the packing results. In this case, I want to see if the runner is big enough or correct for this type of part. The first thing I do is go to the packing. I look at the molten core. Molten core is only a temperature, and in reality the material is not freezing off from one temperature to another. So the molten core gives you an idea about where you are. So we can see here the symmetry. Now we have some temperature inside, and that's of course because it's like having the center temperature inside here. Then I'll right click here for the time stepping. Sorry, up here I'll just click and I'll look here and say okay, 3 seconds. Oh, sorry, 2.3. So we can see now 2.5, 2.9. Maybe the gate size is a bit too small, but this is only a temperature, remember that. So I would say with this, maybe I would not do anything about it. It's quite okay with a size of 0.8. But this is only a temperature. The molten core shows the temperature. But what you can do is that you can go to XY curves here, here, and you can look at the flow rate gate. and then you can see, okay, when do I not have any flow in the gate? It's really hard to see here, but then I have the possibilities to scale it. So I'll just scale it here by double clicking, and the y-axis I'll scale down to when I have 0.1, maybe 0.1. Okay. And then I can use this one tracer, and then I can see that was the wrong, of course. It was the y-axis. Point 1. Enter. Now we see it. And then I can use the tracer here and say, okay, when do I have a flow rate of 0? You can see it changed. And around here, between 2.5 and 3 seconds, but around 2.5 seconds, we don't have any flow in the gate anymore, and it correlates quite good up against these 2.5 seconds. This is dependent on the material. If you have POM or PP, it would not be as significant the difference. Some results that I also use for looking into it is the velocity vector. And now I have a velocity vector, and what I want to show is not the zero velocity. So I'll just change it for 0.1. And then I can see I still have some flow. The blue one is a small flow of 0.1 centimeters per second. I could also make it 0.1, and we can see we have a flow here. And if I take a time step 3.1 second and do the same 0.01, I can see there's a small flow here. We didn't have that in the molten core, but it's nothing here. So I would say that this runner system defined as here would be able to fill this part and pack it with quite good conditions. And then you can ask, should I make these smaller? Yeah, in some cases, if you want to, that you think that they would be cycle time dependent. So you can, if you're not able to eject them, and you have to wait for them before the runner is cooling off. So this is how I look at the runner size and gate size here. If of course I see that the gate is freezing off way too early, I will go back to the mesh file, do a new mesh with a different size, and do the simulation once again. Okay, that's it from here. Bye bye, have a nice day.